First one that I have, Jordan, is very similar to the one that you just asked me, number 24. Yours had a linear expression under the radical. Mine has a quadratic expression under the radical. What's the domain of that expression?
X is equal to positive or negative 3. I mean, it's going to be like, oh, it can't be greater than 3, and it can't be less than negative 3.
So anything between 3 and negative 3?
Yeah.
That sounds right. Anything between 3 and negative 3. What about 3 and negative 3 themselves? Could you let x be 3 or negative 3? Yeah, you can take the square root of 0. That's not a problem. You just can't take square root of a negative. So the domain is from negative 3 to 3, including the endpoints. And then what's the y-intercept? If you let x be 0, you're going to get y as 0. So the x-intercept is the origin, the y-intercept is the origin. The x-intercept, if you set the whole function equal to 0, other than 0, 0, what other x-intercepts would you get? If we set x times square root of 9 minus x squared equal to 0, we'd get x equals 0 or 9 minus x squared equals 0, which would give us the plus or minus 3. So 3 x-intercepts, the origin, negative 3, 0, and positive 3, 0. Does this expression have, or this function have any kind of asymptote? Not a vertical, there's nothing that makes it undefined within its range. No horizontal, no slant asymptote. Here's where I saved us tons of time. Finding the first and second derivative takes a few minutes. And so I know that you're already good at finding derivatives. I just went ahead and gave it to you. I'm going to put none for these asymptotes. And I've gone ahead and given you the first derivative. And actually, I went ahead and told you the critical value of the first derivative. Where did I get that plus or minus 3 over square root of 2? Setting the whole fraction equal to 0, which is equivalent to just setting the numerator equal to 0. If I had 9 minus 2x squared equals 0, then I would have x squared equals plus or minus 9 halves, and x equals plus or minus square root of 9 halves. And square root of 9 halves just simplifies to that plus or minus 3 square root of 2. I wanted to go ahead and get a decimal approximation of it, because if I'm going to plot these points, I need decimal approximations. In the back of the book, if they have the exact answer for all the x's and y's, and I think they do, and you have decimal approximations, that's fine. Make sure your decimal approximation is equivalent to their, or approximately equivalent to their answer, and then just go ahead and give me a decimal so that you can graph it. All right, so the critical value is 2, 1. Critical value for the first derivative is 2, 1. I gave you the second derivative, which takes a little while to find. But then what about critical values of the second derivative? How am I going to find those? Again, set the numerator equal to 0, and you get x equals 0 or x equals what?
Square root of 27 divided by 2.
And plus or minus. Plus or minus square root of 27. Square root of 27 halves. And if you wrote that 27 as 9 times 3, you could take the square root of the 9, just leave the 3 under the radical. you'd still have a 2 under the radical in the denominator. That's pretty ugly. I don't know why I didn't get a decimal approximation of that. Let me see if I have it written down. 24. Yep. Oh, I don't have it written down, but the reason I don't have it written down is that's approximately this, well, that's the square root of 13.5. That's not even going to be in the domain. That's going to be less than -3 or greater than +3. So it can't be a critical number if it's not even in the domain of the function. We found it, but I'm just going to say not in the domain. So 0 is the only critical value that's in the domain of the function. And then I went ahead and made the sign chart, which is very time consuming because you're just plugging numbers into the first and second derivative. Notice that when I put the critical numbers on the number line, I included the -3 and the 3. I can't test anything outside those. They're not even in the domain of the function. So I'm going to draw my solid line to say those are the endpoints of the domain. And then I put my critical numbers for the first derivative, -2.1 and +2.1, and my critical number for the second derivative was 0. So far, so good? Okay. It's this other stuff we're working on. What should I be looking at to determine the increasing intervals? Sign of the first derivative. So where is the function increasing?
2.1 to 2.1.
Can I say that as a single interval, or do I need to break it at 0?
Can you say it's 1?
Yeah, because I don't have a vertical asymptote or any discontinuity between the -2.1 and the +2.1. So I can go ahead and write that as a single increasing interval. And then what are the decreasing intervals?
-3 to -2.1 and +2.1 to 3.
Yeah, you didn't say infinity because 3 and -3 are the endpoints. All right, how do we determine from this sign chart the relative maxima?
First,
Where the first derivative does what?
increases and decreases.
Goes from increasing to decreasing. That's the +2.1. And I went ahead and plugged 2.1 into the original expression, and the y value is about 4.5, 9/2. How do you find a relative minima? By looking at the sign of the first derivative,
Decreases and increases.
where the function goes from decreasing to increasing. That's -2.1. And when I plug the exact value, not just the rounded 2.1, but when I plug the exact value for those x's back into the original function, that's why I have a rational number for my y's. All right, where do I look to determine concavity?
Second.
Second derivative, positive or negative? Which one's concave up?
Positive.
Where the second derivative is positive, so what's the concave up interval in this function? -3 to 0, and concave down? 0 to 3. And is there a point of inflection?
At 0
Because what told you that?
because you go from being concave up to concave down.
That's where the sign of the concavity, or that's where the sign of the second derivative changed, or where the concavity changed, and that's the definition of inflection point. So the inflection point is 0, 0. All right, we have 1, 2, 3, 4, 5 points that we can graph. We have the x-intercepts. We have the relative max, relative min. So plot those 5 points, and then we'll figure out how to hook them up. Is that approximately where your 5 points are? Okay. I found an online grid generator yesterday, so I could give you the exact chart that you needed. Plot that. Let's see. From -3 to -2. -3 to -2, the function is supposed to be, I'm looking back at my sine chart, decreasing and concave up. From here to here, decreasing and concave up. Can you tell what that's going to look like? That's decreasing and concave up. And then from -2 to 0, looking back at my sine chart, that's supposed to be increasing and concave up. Increasing and concave up would look like that. And then from 0 to 2.1, the graph is supposed to be increasing and concave down. Increasing and concave down. And from 2.1 to 3, the graph is supposed to be decreasing and concave down. Ta-da! Cool thing is, you have to do the calculus, you have to show the calculus, but on the test, you don't have to turn that in without knowing you're right, because you have a graphing calculator. You graph it on your calculator, make sure it's right. This format is working much better than the 1 through 5 that I had on the notes yesterday. So for tonight's homework, I brought you blank copies of this so that you can just write down the problem, do all the parts, graph it. Any work you need in finding the derivative, you can do over here on the right-hand side. I just had to think of a better way, because yesterday it didn't go as smoothly as I wanted it to. All right, 24 okay now? All right, everybody's smiling again. 26. You can tell that I did a lot of work last night. If you want to see how I found the x-intercept, setting that equal to 0 was kind of a pain in the butt, but I did it. And if you want to see how I found the first and second derivative and the critical points, that was a kind of pain in the butt too, but I did it, just so that we could move on to the meat of the problem. So, what's the domain of that expression? Is there anything you could not let x be? -2, because why? Maybe right here?
It'd be a negative under the.
Oh, but it's cube root. It's cube root, so you can take the cube root of a negative. So that domain's -infinity to infinity. Jordan, you'd be exactly right if that had been x plus 1 to the 3 halves.
Yeah,
That would have been square root.
I never know which one, like, it's a square root and a cube root, like in the fraction like that.
The denominator is always the index. All right, y-intercept, let x be 0, and what do we get there? 1 minus 3, negative 2. 1 minus 3, negative 2. And let me look where I've already done this one, make sure I don't do anything goofy. All right, x-intercepts, I did my work over here because it took a few minutes. I had to factor out an x plus 1 to the 2/3. Here's what was left inside brackets. And then I set each of those factors equal to 0, solve those two equations. I got negative 1 plus or minus. Hey, don't forget, this would be an easy thing to forget. When you raise both sides to the 4/3 to unexponentiate that, when you raise to the, not 4/3, when you raise to the 3/4 power, you're taking the 4th root of something. So don't forget your plus or minus. If you ever take the even root of both sides of an equation, you're going to have a plus or minus. So x equals negative 1 plus or minus 3 square root of 3/4. And decimal approximations are about negative 3.3 and positive 1.3. And that's all you have to give me, even if the back of the book has negative 1 plus or minus 3 to the 3/4. All you need to give me is, what did I say? Negative 3.30 and 1.30. There are 3 points that I'll graph when we get around to it. What about asymptotes? Does that expression have any asymptotes? No. None at all. And then I found the first derivative, which was painful. And then I looked for what made it 0 or undefined. What makes it undefined is negative 1, and negative 1 is in the domain of the function, so it's one possible relative extrema. The other two possible relative extrema are negative 2 and 0. So I get all three of those critical values of the first derivative, negative 1, or negative 2, negative 1, and 0. And then I found the critical numbers of the second derivative by setting its numerator equal to 0. And right here, what did I realize when I got to x plus 1 to the 4/3 equals negative 1/3?
You can't.
If I raise both sides to the 3/4 power, I'm taking the 4th root of a negative, and the 4th root of a negative is not a real number. So no real solution to that. And what does that tell you about critical values of the second derivative? There are none. What does that tell you about inflection points? There are none. All right, I made my sign charts, chart singular, with the critical numbers negative 2, negative 1, 0 on there. I don't need to put in any endpoints because this domain was negative infinity to infinity. I don't have any vertical asymptotes to make a note of. So I just chose 4 test points, and those 4 intervals substituted into the first and the second derivative. Tell me the increasing intervals for that function. Negative 2 to negative 1 and 0 to infinity. And then tell me where the function's decreasing. Negative 2 and negative 1 to 0. Looking at the sign chart, tell me the x value of the relative maxima, where the function goes from increasing to decreasing. There's a relative max. So there's a relative max at -1. I already substituted that into the equation, the original equation, and got y equals 0, just to save us time. What about relative min? When the function goes from decreasing to increasing at -2 and decreasing to increasing at 0. So -2 and 0 are the x coordinates of the relative min. I've already plugged them in and found the y values. There's 3 more points we can graph. Where's the function concave up? Yeah, second derivative is positive everywhere. So it's concave up from -infinity to infinity, and it's not concave down anywhere. You could say nowhere or not applicable or whatever. We've already said there are no points of inflection. So we have 6 points we can graph from the B part, the C part, the N part, and the O part. Plot those 6 points. That sounds like me playing the piano. Hmm, 5 points, because the y-intercept is also the relative mean. Is that where your 5 points are? Okay. Now, I'm going to look at the sign chart as I hook up these points to make sure I have the concavity right. But from -infinity to -2, it's supposed to be decreasing and concave up. So decreasing and concave up from over here all the way to here. From -2 to -1, looking at my sign chart, that's supposed to be increasing and concave up. And then from -1 to -2, no, I'm sorry, from -1 to 0. -1 to 0, it's supposed to be concave up and decreasing. Decreasing and concave up. And then from 0 to 1 point something, it's supposed to be increasing and concave up. Going better today, Miss Michaela? Yeah. Yeah, I can do this. I can do this. We're taking everything that we learned in 4.1 to 4.5 and we're just putting it all together on a graph. Nothing really different in 4.6. All right. Can you handle one more? What about a trig one? Oh, yeah. I haven't done much of the work on this one. Number 38, f of x equals 2 times x minus 2 plus cotangent x. We're only supposed to graph it from 0 to pi. So from 0 to pi, that's just half a revolution of the unit circle, what's the domain of that function?
Zero to
Can't be a pi half.
I have to think about cotangent because cotangent has vertical asymptotes somewhere. I need to figure out if it's whole pies or half pies. Cotangent is cosine over sine. And so wherever sine is 0, cotangent's undefined. And I'll just make a note over here. Where sine x is 0, cotangent x is undefined. Sine is 0, yeah, at the whole pies. So I don't have to exclude a half pi, but I did need to check for that. If that had been tangent instead of cotangent, I would have had to exclude the half pi. So this is defined from 0 to pi, including those endpoints. What about y-intercept? What's f of 0?
When there not be one, because
There's not a y-intercept because,
0 makes cotangent.
yeah. So I'm not saying we can't find the y-intercept. I'm saying this doesn't have a y-intercept. All right, what about x-intercept? Trying to remember, have I worked this whole problem yet? I don't think I have completed it. It was pretty yucky to find the x-intercept. So it does cross the x-axis, but I promise on the test to give you one that is either easy to find the x, not easy, but
doesn't take
Yes.
15 minutes.
doesn't make you just want to change your major to PE to find the x-intercept, or I just won't ask you for the x-intercept. So here I'm just going to put question marks. There is one, but we're not going to take time to find it. That would require some new wrinkles on my forehead. What about asymptotes over the domain from 0 to pi? There are going to be asymptotes at 0 and pi. And since those are included in the domain, I need to say x equals 0 and x equal pi are vertical asymptotes. There's not a horizontal asymptote or a slant asymptote. Now, it didn't take long to find the first derivative. I could do that term by term. 2 minus cosecant squared x. What I left for us to figure out is the critical numbers. And as you're doing your homework tonight, find your derivatives, find your critical numbers over here in the blank space, and anything that you have to show work for, just label which part you're working on. On part G, to find the first derivative, or the critical points of the first derivative, I would say 2 minus cosecant squared x equals 0. Or, what makes that undefined? What makes cosecant undefined?
Wherever sine is 0,
which would be,
0, and
but we already know what's going on at 0 and pi, so we don't have to list them as critical numbers. The function's undefined there. All right, we had to think about it though. So I'm going to add cosecant squared to both sides and take the square root of both sides. And when I took the square root of both sides, I got my plus or minus. Can I solve that without a calculator? The answer is yes, but how?
cosecant is 1 over sine.
Mm-hmm.
So sine will be the reciprocal.
Yeah, if cosecant is square root of 2, then sine is 1 over square root of 2. And at first, I don't recognize that as anything I have memorized on the unit circle. I could certainly punch it on the calculator using arc sine. But then I realize if I rationalize that denominator, it's plus or minus square root of 2 over 2. And so I can tell you where in the unit circle, and we're just talking about first or second quadrants here, where sine is square root of 2 over 2. If we write that as radians, what would it be? Pi over 4 and 3/4 pi. So those are the critical numbers of my first derivative. Wasn't difficult to find the second derivative because the derivative of negative cosecant squared, you might need to write that as 2 minus cosecant x squared with that exponent outside before you differentiate it. The derivative of 2 is 0. And then if I bring this 2 out front, I have negative 2 times the derivative of cosecant. The derivative of cosecant is cotangent cosecant, and a negative times a negative gives you a positive. You want to see that written down, or are you okay with that second derivative? Okay. All right. So what about critical values of the second derivative? Thankfully, it's factored for us. What makes cotangent 0? Set each factor equal to 0. Where's cotangent 0?
Where cosine is 0.
Yep, and where is that?
Pi over 2.
All right. And where is cosecant 0? The face made the right expression. Yeah. Cosecant is never 0. If you think about what the graph looks like, it doesn't have any x-intercepts. It's this, but not touching the x-axis. So if that doesn't have a solution, the only possible inflection point is at pi over 2. And then I made my sine chart from 0 to pi. Since those are endpoints, I want to make a solid line saying I'm not going past 0 and I'm not going past pi. And I put my three critical numbers on there, pi over 4, pi over 2, and 3/4 pi. And I made the sign chart because that's the slowest part of this process. Looking at that sign chart, tell me the increasing intervals.
4 to 3, 5, 4.
Wherever the first derivative is positive, pi over 4 to 3/4 pi. Decreasing intervals.
0 to 5 to 4,
Mm-hmm.
and 3 plus 5 to
How do you find relative maximum looking at the pie chart?
Right, goes from increasing to decreasing in the first derivative.
And so that would be at 3/4 pi. And I already found the y value to be approximately negative 0.29. And then the relative mean is where the first derivative goes from decreasing to increasing. That's at pi over 4. And I already got the y values about 1.43. Can somebody, real quick, I should have gotten decimal approximations of 3/4 pi and pi over 4. Pi over 4 is about 0.7-ish.
3/4 pi is like 2.35.
Okay, so let's just call it 2.4. That's probably as precise as we could graph anyway. And then pi over 4 is about 0.7 or 0.6? 0.79, darn close to 0.8 then. Now, if I had been able to, on the generator I was using, if I had been able to label my x-axis by half pies or quarter pies, I would have. But the program I was using, I couldn't label an axis in terms of pi. I could only use decimals. So that's why I needed decimal equivalents or approximations of the relative max and min. Where's the function concave up?
0 to pi over 2.
Wherever the second derivative is positive, that's 0 to pi over 2. Concave down, pi over 2 to pi. And what's the x-coordinate of the point of inflection?
Pi over 2.
Where the concavity changes from up to down. So pi over 2, or when we plot that, we're going to call it about 1.6-ish, negative 0.86. All right. I need to graph those vertical asymptotes at 0 and pi. 0 is already a solid line. Pi is approximately 3.1. And then I don't have a y-intercept or an x-intercept that I can plot. I do have an x-intercept, I just don't know exactly what it is. So the only other points I have are the relative max, relative min, and point of inflection. Plot those three. Is that about where you have your 3 points? All right, from 0 to pi over 4. And I'm going to come up here on my sign chart and say pi over 4 is about 0.8. Pi over 2 is about 1.6. And 3/4 pi is about 2.4. So from 0 to 0.8, the graph should be decreasing and concave up. From 0 to 0.8, but not including the 0 because we don't have a y-intercept. So decreasing and concave up will look like that, with this being a vertical asymptote. From about 0.8 to about 1.6, the function should be increasing and concave up. From about 1.6 to 2.4, the graph should be increasing and concave down. Increasing but concave down. And then from 2.4 to pi, not including pi, the graph should be decreasing and concave down, approaching that vertical asymptote. Okay? All right. Let me give you some of these blank pages to do your homework on. Don't redo the ones that you've already done in this format, but the ones that you haven't done, do them on these pages. You're welcome. You're welcome. So if you finished last night's homework, where's my one page? If you finished last night's homework, then you already have these 1, 2, 3, 4, 5 problems, and you only have 1, 2, 3 to do tonight. But any that you have not finished of these 8, then get them done tonight. And notice I cut that homework to only 4 problems tonight instead of 3 problems tonight. All righty. See ya.